Ever wondered how the universe's essential building blocks, atoms, are structured? It's a fascinating world, yet immensely significant. Today we'll delve into this miniature universe with some multiple-choice questions that will test and expand your understanding of atomic structure. First up, what are the three primary particles that make up an atom? A. Electron, proton, and neutron. B. Electron, proton, and molecule. C. Ion and molecule. D. Ion, proton, and neutron. Correct answer is A. An atom comprises electrons, protons, and neutrons. Electrons carry a negative charge, protons a positive charge, and neutrons have no charge. Next, where can you find these particles in an atom? A. Protons and neutrons in the nucleus, electrons in the electron cloud. B. Electrons in the nucleus, protons and neutrons in the electron cloud. C. All in the nucleus. D. All in the electron cloud. The correct answer is A. The nucleus, situated at the center of an atom, houses protons and neutrons, while electrons populate the surrounding electron cloud. Which atomic particle determines the chemical properties of an element? A. Electron, B. Proton, C. Neutron, D. All of the above. The correct answer is A. Electrons, particularly those in the outermost shell, determine an element's chemical properties. Which atomic particle determines the atomic number of an element? A. Electron, B. Proton, C. Neutron, D. All of the above. The correct answer is B. The atomic number of an element equals the number of protons in its nucleus. What is an isotope? A. Atoms of the same element with different numbers of protons. B. Atoms of the same element with different numbers of neutrons. Atoms of different elements with the same number of protons. D. Atoms of different elements with the same number of neutrons. The correct answer is B. Isotopes are atoms of the same element that have different numbers of neutrons, resulting in varying atomic masses. Now that we've understood isotopes, let's dive deeper into one of the primary atomic particles, the neutron. You might be wondering, what is the charge of a neutron? Well, let's break it down. Neutrons, along with protons, reside in the atom's nucleus. Unlike protons, which carry a positive charge, and electrons, which carry a negative charge, neutrons do not have an electrical charge. They are neutral particles, which means they carry no charge. Why is this important? The neutrality of the neutron helps to balance the positive charge of the protons in an atom's nucleus. Without neutrons, the repelling force between protons would cause the nucleus to disintegrate. So, to answer the question, what is the charge of a neutron? The correct answer is it's neutral. Neutrons are neutral particles. They carry no charge. This neutrality plays a crucial role in maintaining the overall stability of an atom. In the next scene, we'll wrap up our discussion on atomic structure. But remember this, every tiny particle in an atom serves a purpose, contributing to the unique properties of each element. Our journey into the atomic world continues. Now you might be asking yourself, what is the mass of an electron compared to a proton? Well, let's delve into that. Both electrons and protons are fundamental particles in an atom, with electrons revolving around the nucleus that is made up of protons and neutrons. But when it comes to mass, there is a stark difference between them. The mass of a proton is approximately 1,836 times greater than that of an electron. Yes, you heard that right. Electrons are much, much lighter than protons. So, if you were to put them on a scale, the proton would easily outweigh the electron. This difference in mass is fundamental to how atoms behave and interact. So, when asked, what is the mass of an electron compared to a proton? The correct answer is, an electron is much lighter. Remember, every tiny detail in an atom's structure, even the mass of its particles, plays a crucial role in defining the properties of the elements. Let's move on to our final discussion on atomic structure in the next scene, keeping this fact in mind. We've just talked about the masses of electrons and protons. Now let's shift our focus to the capacity of electron shells in an atom. You might be wondering, what is the maximum number of electrons that can fit in the second shell? The answer to that lies in the electron shell rules. According to the rules, each shell of an atom can hold a definite number of electrons determined by the formula τ squared, where n is the number of the shell. So for the second shell, or n equals sign 2, the formula gives us 2.2 squared equals sign 8. Therefore, the correct answer is 8 electrons. Yes, the second shell of an atom can hold a maximum of 8 electrons. This capacity is crucial in understanding atomic structure and behavior, as it determines how atoms will interact with each other during chemical reactions. With this knowledge, we are now ready to wrap up our discussion on atomic structure in the next scene. Today, we've explored the fascinating world of atomic structure, from understanding the primary atomic particles, electrons, protons, and neutrons, to learning about their specific roles and positions within an atom. We've also delved into the concept of isotopes, a testament to the complexity and diversity of atoms. Remember, the universe's mysteries lie not only in the vast expanses of space, but also in the smallest atom. So exploring, keep questioning, and keep learning. Until next time, stay curious and stay inspired.